This example has a special place in the history of mathematics. One of the powerful reasons we learn this abstract mathematics or this theory of orthogonality and orthonormalization is because we know that things other than vectors behave like vectors, and in particular, functions behave like vectors. And so this is an example with functions. And we're going to see that everything that we could do for vectors, we could do for functions. Everywhere that it said dot product before, or like a row times a column, is now going to be an integral, where we find the inner product of two functions. We're going to integrate the product of those two functions from -1 to 1. So the result is that we're taking these three polynomials, 1, x, and x squared. We know that they form a basis for the quadratic functions. We're going to find a basis that is for the quadratic functions that is orthogonal. If you integrate 1 times x squared, you will not get 0. So 1 and x squared, they're not orthogonal to each other. You should think of them as not 90 degrees. The polynomials that we'll get at the end of this example, if you skip to the end, you'll see that we get a 1 over square root 2 for q1 hat, and q3 hat will be 3 square root 10 over 4, all of that times x squared minus 1/3. So now those polynomials, just like our matrix, our QR matrices, the numbers were uglier as far as square roots and stuff goes, but the properties are nicer. If you multiply the q1 hat with the q3 hat and integrate from -1 to 1, you will get 0. Those two polynomials, as ugly as they might look to you when you're unfamiliar with this stuff, they have the nice properties. And so you'll see that this example does not have videos posted all up and down it like the last one did. That's because, that's right, I want you to go through all of the steps without me having to show you what the steps are. If you need someone to show you what the steps are, what you should do is go back to previous videos, to the definitions. And this is an exercise in do you know where to go to find what you need? Of course, if you just can't find it and no one can tell you, email me. But the goal is for you to be able to read through this example and for you to actually do the integrals on your own to verify all of the steps, and then see if you can do that homework problem that will have you find the cubic polynomial that will just go with this set.